In this video, what we will look at are our inequalities, and specifically, we will be looking at the system of inequalities. And our essential question will be, how do I graph a system of inequalities? So let's take a look at your reading graphic aid here, your graphic organizer. And I'm going to point a few things out to you here, and then you're going to do the three at the bottom on your own, and then you will submit those to me in Google Classroom. So let's take a look at our first one. What we have here is we have the inequality of y greater than x minus 2. So how we would graph that is we would just do y equal to x minus 2. Our lines that we have in systems of linear inequalities, we call those boundary lines. So this is what you graph. So our boundary line for this one is y equal to x minus 2. So we come over and graph it. We see that we have our intersection, or y-intercept at -2, and a slope of 1. So as you see, we have risen 1, run 1. Now, coming over here, when we graph that, you notice that they used a dotted line. You use your dotted line when your inequality symbol is a greater than or a less than, right here, those two right here. I would like for you to compare that. Your dotted line is essentially what we would compare as our open endpoint when we were looking at our interval notation. Remember that open endpoints mean that the endpoint is not included. So when we do a dotted line, that means that the dotted line is not included in our solution set. Now, notice now it's more than just a line, it's actual shading. Notice that they have shaded above the dotted line. They shaded above the dotted line because it was greater than. But we can always check that. So here is our check right here. We are going to check our point 0, 0. We're going to actually put it into this equation, which is what they're doing here. So I'm going to do it over here on the side. So if I have point 0, 0, my y value is 0, my x value is 0. So I'm just replacing those in. And let me do my inequality on these though, greater than. And so now I have 0 greater than a -2. This is a true statement, and my 0, 0 is right here. So since it's a true statement, I will shade where my 0, 0 is, and my shade occurs right here. Now, let's look at our second one here. Our y less than or equal to 2x plus 2. So our boundary line itself will be y equal to the 2x plus 2. Now notice this time our boundary line is a solid line. If you notice that your inequality symbol now does include the equal sign. Since we have that equal sign, we relate that is the same thing as a closed endpoint. Okay? Meaning that the boundary line is a part of your solution set. So we graph it. So we look over here, we have an y-intercept of 2 and a positive slope. So we will go up 2 and run 1, so right there, and we draw in, and it is a solid boundary line. Now we're going to do the exact same thing we did with the other one. We're going to use the origin as our test points here. So I have y less than or equal to the 2x plus 2. Now let's replace in our values, y being 0 and our 2 being 0. So if I multiply 2 times 0, that would give me 0 plus 2, which would be 0 less than or equal to 2. Is 0 less than or equal to 2? Yes, this is a true statement. So you see where your origin is, and you shade on that side of the line. So this is where they got that shading. Also notice that in this one, the shading was below the boundary line. That is also because when you look at your inequality symbol, it was a less than or equals. So your less than, equals, or your less thans would produce shading below. And since it included the equal sign, our line was solid. So when we go down to our second one, or our third one, sorry. So now they show it with our brackets, how we look at systems of equations. They're presenting it to you in the same way. So you are combining both of those together on one coordinate plane. And when you do that, you find that, in fact, you end up with a shaded area where they both meet. So when you look at this, you see that both of those, when you combine them, end up with an overlap. And when you have that overlap, we call this the double shaded area. That is the solutions to your system. And if you'll notice, you see that 0.00? That was true over here for our first one, and it was true as well over here for our second one. You see that it does, in fact, lie inside that double shaded area. All right, so I would like for you to go ahead, come down, and work questions 1, 2, and 3, and submit those to me before class.